This is page 28. So it says selecting a male member of the chess club whose members are Samuel, Martha, Carol, Joanne, Sally, Ronaldo, and Simon. So the outcomes, since they want male, we have males and females for the possible outcomes. And so the probability of selecting a male member. So there's Samuel, Martha. So first of all, the total number of members would be 1, 2, 3, 4, 5, 6, and 7. So there are 7 total possible members that we can select from. We have Samuel for male, Ronaldo for male, and Simon for male. So we have 3 males over 7 possible. So it's going to be 3 over 7. For female, we have Martha, Carol, and Joanne, Sally. So there's 4 over 7. Notice how when you add them all up, it's 3 over 7 plus 3 over 7 plus 4 over 7, we get 7 over 7, which is equal to 1, which we want, okay? If your probabilities do not add up to 1, that means you probably did something wrong. You made a mistake in counting and so on, okay? So they all should add up to 1, okay? And notice how this is a non-uniform probability model because the probabilities are different. Number 2, it says use a probability model to calculate each probability. So now we're given this model and we're just figuring out the probability of choosing 3, which is, it's right there, right? Probability of you choosing 3 is 3 over 12, but you can simplify that as 1/4. How about B? It says probability of choosing an 8. Okay, notice how there is no 8. It ends in 7. It ends on 7, so it's going to be 0. It's not possible for you to roll an 8 or choose an 8. Okay. And for C, probability of you choosing number less than 8. Notice how if it's number less than 8, all of these numbers count, right? Because 2, 3, 4, 5, 6, and 7, they're all less than 8. So we can say 1 over 12 plus 3 over 12 plus 1 over 12 plus 5 over 12 plus 1 over 12 plus 1 over 12. Okay, so we can say that they're all equal to 1 because we know that each probability model should add up to 1. So so if you want to check your work, 1 plus 3 plus 1 plus 5 plus 1 plus 1 would be 12. And probability of you rolling a prime number. So just a reminder, prime numbers are positive integer greater than 1 that is not divisible without a remainder except itself and 1. So in this case, the prime numbers are going to be, 2, right? 3, 5, and 7, right? 4 can be divided by 2, like 2 and 2 evenly. 6 can be divided by 2 and 3 evenly. So these don't count. These are called composite numbers. But since we're focusing on prime numbers, these are going to be 2, 3, 5, and 7. And so the probability of you rolling a 2 is 1 over 12. And probability of you rolling a 3 is 3 over 12. Probability of you rolling a 5 is 5 over 12. Probability of you rolling in 7 would be 1 over 12. So when you add them all up, 1 plus 3 plus 5 plus 1 is equal to 10 over 12. We can simplify that to 5 over 6. Okay. So since there are multiple prime numbers, we had to just add them all up. So add those prime numbers up, the probability of you rolling prime numbers up, okay? So it's not just going to be 2 or 3. Since there are 2, 3, 5, and 7 as prime numbers, we're just going to have to add the probabilities for each of them to get the sum, okay? And lastly, probability of you rolling an even number. Even numbers are 2, 4, and 6 from this model. So we can say 2 is 1 over 12, so we write 1 over 12. And you rolling a 4 would be 1 over 12, so we add 1 over 12. And same thing for 6, it's going to be 1 over 12 as well. So when you add them all up, you get 3 over 12, which simplifies to 1/4.